So welcome to Aviation Safety Management Systems. To get started in this course, we need to set some foundational concepts. These are clearly articulated in your reading material and presentations, but I wanted to take a moment and explain some of them to you in this video. So first of all, what is safe? The dictionary definition defines safe as being free from undergoing or causing hurt, injury, or loss. So that's free from receiving hurt, injury, or loss, or free from being liable of causing hurt, injury, or loss. However, we are in upper level education and the dictionary definitions can be a bit rudimentary for us. It requires some deeper digging. After all, are we ever free, 100% free from the potential of hurt, injury, or loss? No. When you drive, are you safe? You can crash. When you walk, you can trip. When you exercise, you can pull a muscle. If you never get out of bed, you risk lethargy, bed sores, diabetes, weight gain, and a plethora of other unhealthy phenomena. So let's move this concept of safe into our world of transportation. Is transportation safe? Well, yes and no. If you are one of the millions of people who reach their destination without incident, you might say yes. There's a very slight probability in commercial aviation that you will become an accident statistic. There's a much greater probability in general aviation that you would become an accident statistic, but we'll cross that bridge a little bit later. In commercial aviation, you have a 1 in 4.9 million chance of reaching your destination alive. If I were a betting man, I would probably take those odds. But what if you were that one that didn't make it to your destination? Is that acceptable safety? Rather than free from harm, rather than 100% free from harm, in aviation we classify safety in terms of risk. Aviation is a dangerous business with a very good safety record in commercial aviation. Not so good safety record in general aviation, but we identify the level of risk and then see ways to mitigate the risk to an acceptable level. That said, here's a definition of safety from the International Civil Aviation Organization that we will use for our class. Please pay attention to the underlined words. We're going to go deeper into them in the next slide. Read that definition of safety to yourself. Ready to move on? Here we go. Those underlined words. In the safety definition, we identified risk. That is the composite probability and severity of a mishap. The probability that a mishap will occur and the consequences if it does. Risk is reduced to. That is, controls are put into place to mitigate the identified risk. You ride your bicycle on a busy street, you have a high probability of being hit by a car and suffering severe injuries. You wear a reflective vest to reduce the likelihood of getting hit. You become more visible. And you wear a helmet on your bicycle to reduce the severity of injury if you do get hit. Okay, so we have risk, reduced to, now maintained at. We don't just put controls in place and then forget about it. We continually evaluate and re-evaluate the risk. Perhaps in our example of riding a bicycle on a busy street, we decide to take a different route that is less busy. Go at a different time of day. All different ways of reducing the risk and maintaining the risk at an acceptable level. Well, speaking of acceptable level, that's the next element here. Acceptable level, even with a reflective vest and a helmet, we still assume risk while riding our bicycles on a busy street. There are drivers distracted on their cell phones. Don't ever do that as you drive, please. We acknowledge that there will always be risk in what we do, but we measure it and determine whether or not it is reasonable and tolerable. That leads me to one of my favorite quotes in aviation, written by Wilbur Wright. In flying, I've learned that carelessness and overconfidence are usually far more dangerous than deliberately accepted risks. So we identify hazards and manage the risks of those hazards. So let's delve deeper into those two terms. Risk, as we alluded to earlier, equals likelihood times severity. You will see later on in the course that we can describe and assign numerical values to severity and to likelihood. Those ratings, taken in concert with each other, give us risk that can be plotted on a risk matrix. The risk matrix gives us a visual depiction of severity, should an event occur, and likelihood that the event would. The resultant risk is either acceptable with mitigation, or unacceptable. It's a very nice visual view of the level of risk that we are considering. We also talked earlier in this video about hazards. In safety, we intentionally seek out and identify hazards because it is the hazard left unabated that can lead to unsafe conditions and mishaps. This is crucial and is on your quiz and test. A hazard is a potential threat. It's not an active occurrence, it is a tree, a cliff, as in your Calvin and Hobbes cartoons in the PowerPoint. In aviation, a hazard is, an example of a hazard is a thunderstorm. It's mountainous terrain, those sorts of things. It may not impact your operation, yet the hazard is still there. Your risk analysis will determine whether or not the hazard impacts your operation. Hazards are ever present. Seek them out. So we have reasoned now that safety is a continual process of risk mitigation. Risk is an objective measure of the severity and probability of a mishap that results from a hazard. A hazard is a potential thing, something out there that could cause harm. So this was to present you with a foundational understanding of these key concepts. I hope you enjoy the course and find that you can practically apply this material in your daily lives and professions.